A driver and passenger are in a car accident. Each of them independently has probability zero point 0.3 of being hospitalized. When hospitalization occurs, the loss is uniform on 0, 1. When two hospitalizations occur, the losses are independent. Calculate the expected number of people in the car who are hospitalized, given that the total loss due to hospitalization from the accident is less than 1. So let T be the total number of people who are hospitalized, because that's an important part of what we need, number of people who are hospitalized. So let T be it. So it'd be 0, 1, 2, because either none of them will be hospitalized, the driver and the passenger, or one of them, or both of them. Now, when T is 0 or 1, of course, when T is 0, loss is less than 1 because there's no loss. And loss is only occurring when you're hospitalized, and T is the number who are hospitalized. So when T is 0, there is no loss, and so loss is less than 1. We care about the loss being less than 1 because that's the given condition. The total loss due to hospitalization from accident, given that the total loss due to hospitalization is less than 1. So when T is 1, again the loss is less than 1 because loss is uniformly distributed from 0 to 1. So it cannot go outside the 0 to 1 range. So again it will be less than 1. But when T is 2, since each of the loss goes from 0 to 1, so the total loss goes from 0 to 2. And therefore, because of the symmetry and the uniformity, the probability of the loss being less than 1 in this case will be 0.5. The probability of loss being bigger than 1 will also be 0.5 because it's symmetrically uniformly distributed, the two of them. So this is the situation. T, remember, was the number who are hospitalized. Could be 0, 1, 2. Let's look at the probability of 0 hospitalization. Means none of them is hospitalized, and we are given that the probability of hospitalization is 0.3. Let's scroll up. Yeah, the probability of hospitalization is 0.3. So none of them hospitalized means 0.7 times 0.7. 0.7 is that one of them is not hospitalized, and the other one not hospitalized is also 0.7. And so n means multiplication. And in this case, the probability of loss being less than 1 is 1. And therefore, the probability T is equal to 0 and loss is less than 1 equals, this is a probability T equal to 0 and means multiplication, loss less than 1 is 1. So you get 0.49. So now T is equal to 1 means one person is hospitalized. Now that will happen, that can happen in two ways. Either the driver is hospitalized and passenger is not hospitalized, and so you have 0.7 times 0.3, or means addition. You can have the driver being not hospitalized and the passenger being hospitalized. So again, in either case, both of them have the same probability. So hospitalized, driver not hospitalized and passenger hospitalized, or driver hospitalized and passenger not hospitalized. So that ends up being 0.42. And similarly, you multiply. In this case also, probability of loss being less than 1 is 1. And so probability T is 1 and loss is less than 1, be 0.42 times 1. And finally, probability that two of them will be hospitalized is 0.3 times 0.3, because 0.3 is the probability of one of them being hospitalized. So that's 0.09. And in this case, as we talked above, the probability of the loss being less than 1 is 0.5. And so probability t equals 2 and loss less than 1 would be 0.09 times 0.5. And we did all this in order to calculate the probability of the loss being less than 1. So probability of loss less than 1 could be t is equal to 0 and loss less than 1, or t is equal to 1 and loss less than 1, or t is equal to 2 and loss less than 1. And ors mean addition, so you add these three to give the probability of loss less than 1. So that comes out to be 0.955. And eventually, the goal was to calculate the expected number of hospitalizations given loss is less than 1. So expected value of t was the number of hospitalizations given loss is less than 1. And for this expected value, we need the corresponding probability ft given loss is less than 1. And ft given loss is less than 1, we use our basic formula with the probability of t equals t and loss less than 1 divided by probability of loss less than 1. And that is the reason why we needed the loss less than 1, which we calculated here to be 0.955. And so we substitute this 0.955 for loss less than 1. And now we make another table, our final table, which will be based on what we need. We need the expected value of this. So we need this and its probability. So t given L is less than 1, again, it could be 0, 1, or 2. And probability t equals t and L is less than 1. So this we just copied the corresponding. So that's the same thing as we had in the above table. T equals t and L is less than 1. Let's slowly go up. So t equals t and L less than 1. I just copied it. And then f of t given L is less than 1, no, the probability of t given L is less than 1 equals probability of t equals t, and L is less than 1 divided by probability. Okay, we already talked about this. That's going to be this. So this column is basically this column divided by 0.955, and you get these values. Now, since you needed the expected value of t given L less than 1, so you multiply these t given less than 1 by their corresponding probability. So basically column 1 and column 3, 0 times 0.5131 plus 1 times 0.4398 plus 2 times 0.0471. So that's just like that formula where we do summation x fx. So in this case, x is t given L less than 1. So it comes out to be 0.534, that is choice B.